BTEC Applied Science Unit 2, Calorimetry. This is assignment B, Calorimetry. The first thing I'd like to say is that Calorimetry is a rubbish title. Why? Because you've probably just done an assignment on colorimetry. What are the chances of getting them muddled up? A lot of students do. This is calorimetry. I think a much better title would be cooling curves, because what you're going to do is you're going to measure the temperature of stuff cooling down. Like this substance will be, initially it will be a liquid and it will cool down, and you will measure its temperature as it cools down and plot a graph of it and then discuss what it means. Okay, now the seems very basic, but you'd be amazed how many students don't know this. The temperature of an object is how hot it is. Okay, temperature is hotness or coldness. Okay, now obviously it has something to do with heat energy. The more heat energy something has, the hotter it will be, but temperature and heat are two different things. Temperature is how hot something is, and we measure temperature in degrees centigrade. Degrees centigrade, it's the same as Celsius, but I'm going to call it degrees centigrade. Okay, degrees C. And if a substance has lots of heat energy, then if it has a higher temperature than its surroundings, it will lose heat energy to its surroundings. It will, by conduction, convection, radiation, it will lose heat energy, and as it does so, its temperature will fall. Its temperature will get less, and we're going to measure its temperature. We're going to measure temperature and time as it cools down. What kind of thermometer are we going to use? Well, you have a choice. You could use a liquid in glass thermometer, pretty straightforward bog standard thermometer, which has some kind of a liquid which expands and it moves up the tube and it tells you the temperature. Or you could use a digital thermometer, some kind of electronic device which has a probe, a temperature probe. Now, which of these would be better to use? And this is something that you should investigate and discuss. Which kind of thermometer are you going to use? Which will be more accurate? When I say accurate, I mean which will give a reading which is closer to the true value. The true value is the actual value, what the temperature is, and the closer you are to the true value, the more accurate the reading is. Which is easier to use? Which one can you just get out of the cupboard, put it in whatever, tells you the temperature? Okay, doesn't need batteries, you don't have to set it up or press any buttons or twiddle any knobs. Which is easier to use? What is the resolution of each thermometer? The resolution, by that I mean what's the smallest temperature difference that it can measure? Usually this would mean the smallest scale division. Our glass thermometers, the ones that I could use for a glass thermometer, has a resolution of 0.2 degrees centigrade. The digital ones can either be 0.1 or 0.01. Now, that doesn't necessarily mean they are better. Which is a suitable resolution for this experiment? I am deliberately not using the word precision because that word is very often badly used. I'm using the word resolution. Which has a more suitable response time? The response time is the time it takes to give you the correct reading. If I put the thermometer in hot water, how long does it take to tell me what the temperature is? That is the response time. And then which is more reliable? Okay, reliable meaning if I use it again and again and again, it gives the same answer. Okay, it is reliable. I can rely on it. Talking about accuracy, something that you should do for both types of thermometer is test how accurate they are. How do you test how accurate they are? You put them in icy water, pure water, icy water, which should be at 0 degrees centigrade, and then heat up the water until it boils. Good practice doing a graph of temperature against time, this, yeah? So put it in icy water at 0 degrees centigrade, see what it says, heat up the water, measure temperature against time, and then look at the graph. What should the graph look like? Well, now here is a correctly formatted table and a graph. Looking at the table, notice that I've got column headings with units. Okay, I've got my times there, I've got my temperatures there. The temperatures are to the nearest 0.2 because for this particular table, this was my glass thermometer. And looking at my graph, I'm using most of the graph paper. I've got labeled axes with units and I've plotted the points correctly. Because I did this on Excel, I haven't actually done a curve joining the points, but if I did it on paper, I would certainly do that. So a correctly formatted table and graph. Looking at the table, my water is starting off at just about 0 within 0.2 degrees, and it's ending up at 100 within 0.2 degrees. That is a tolerance of 0.2%. I'm happy with that. You know, that would be a suitable thermometer to use. Something you should certainly mention in your report is what you would do if it gave a rubbish reading. If this thermometer said 105 degrees centigrade, what would you do? Would you just chuck the thermometer in the bin and try another one? Would there be some way of calibrating it? Okay. So before you do the cooling curves experiment, you're going to test the accuracy of 2 different types of thermometer, and you are going to evaluate them. To evaluate means you're going to say what the advantages and disadvantages are and make a decision based on that. And you're going to do a risk analysis, and hopefully you can do that as well.